I'm Simon Parkinson. I'm the managing director at an IBM business partner called Dot Group. And today you're going to hear about two things in the main, but we're going to talk to you about one of IBM's recent acquisitions, a product called StreamSets. We bought from Software AG last year, and Dot Group are championing the go-to-market for IBM for this particular product. We've been desperate for it for several years and are very excited about how it's going to hopefully unlock a lot of new modern use cases for data engineering in the UK. So today I've got a whole bunch of panelists. We're not going to go through introductions. You can see, just because we've got a huge amount of content to talk about in the time, but you can see who are on the call. We've got Jordyn, Giuseppe, and Jordyn, who are experts in the field of StreamSets. And the secondary topic we're going to introduce you towards the end into IBM's latest, imagineering of this new data engineering product called watsonx.data integration. So there'll be a section on the end to talk about that, and then Jordyn will brief you on the fact that we're going to have a further webinar in about a month's time on the 2nd of July, also at 3 p.m. to talk about watsonx.data integration. So without further ado, I will hand over to you, Giuseppe, to take them through the content that we've spoken about.
Yeah, thank you. Thank you very much, Simon. Really what we want to cover today, as Simon has mentioned, is primarily StreamSets and what it brings to the data engineering teams. Of course, let's start maybe talking a little bit about the challenges that teams like yours face every day. And we can have a look at then some of the capabilities that we can bring to bear now to tackle some of those challenges. Jordyn will, interesting thing, we will also have a couple of demos, so you will see the product in action, which is always good. Jordyn will then cover really the further evolution of the data integration tool set that IBM provides. So there's a lot going on within the IBM labs, and we will talk a bit about that. And at the end, we will have also time for a Q&A. So I think as we go through the content in this webinar, if you have any questions, please pop them into the Q&A space, and I will review them at the end. So, as mentioned, what kind of challenges do we see today? And I'm talking about we because we work very closely with a lot of companies like yours, and what we keep hearing is that everybody's trying and investing in AI, but AI is constrained by an engineering problem. And what are those engineering problems are really related to data engineering. So if we look at what data engineers look like, well, that's probably some of us in the room on a Monday morning, scratching our heads on how we're going to solve the challenges that are coming from the business. 90% of of the data-related work seems to flow through the data engineering teams. So there is a lot of workload. And to compound the problem, data engineering teams also spending a lot of time having to do maintenance on existing pipelines, existing data flows, and so on. And those are, so it's very important statistics. I think it's important to keep those in mind. We are really trying to tackle both of those by obviously bringing some level of productivity tools to address the top of the line stuff, but also the tools that we provide need to address that issue of pipeline brittleness and the onus on the data engineers to maintain those pipelines. That said, that is not enough of a problem. The other side of it is that, of course, the world in the last 5 to 10 years has changed massively. So regardless of the industry that we're in, organizations really want to make decisions faster, more frequently, and based on up-to-date data and insights. And clearly, if the data are that are flowing through the pipes and replenishing the analytical systems are stale, then that can result in poor decision making. And of course, as a consequence, it's got costs for the company. Could be opportunity loss or just inefficiencies in operations. So clearly, those are the kind of challenges that we want to address. And specifically StreamSets, we've really been focusing a lot on this, reducing the time that it takes to deliver data into decision-making systems, analytical platforms, or other types of building applications that process data as it flows through the pipes. So really getting into a little bit of detail then, what does that look like in terms of types of projects that we get involved in? Well, of course, analytical flows. So getting data from source systems, operational systems, typically IT, but it could be also operational systems in factory floors or logistics, etc. And getting that data into the classic analytical platforms. Notice that the platforms keep changing, maybe a little bit different from what they were 10 years ago. So more and more cloud-based systems, not necessarily so all the time, but we see a lot of movement towards data lakes, lake houses, and cloud warehouses. So you can see some of the logos there, of course. Another big area of investment is that of sort of event-driven architectures. So whether they're based on a backbone such as Kafka or similar, it doesn't really matter. And a lot of time is a matter of basically getting data into these in and out of these backbones with everything that is connected to them. And then there is a third big area of adoption, which is really in the sort of data activation flows, and those are really kind of either analytical or in-memory databases of some sort that sit behind content serving applications or applications front ends where there is a need to have up-to-date data refreshed in real time, enriched, of course, through the pipelines with some kind of additional content, but facing the front-end applications. And of course, these kind of systems and architectures need to support the use cases that are specific to the business that you're in. These are some of the industries and some of the use cases that we see. We have customers that span across all these industries. Of course, big area of investment, as usual, is financial services, banking, and insurance. They always spend a lot of money on data and data integration, of course. But we see also a lot of spend in retail. For example, customers of ours using StreamSets to replenish and maintain up-to-date customer 360 kind of systems in order to provide promotions, for example, or logistics, where we partner with and supply our technology to, for example, Siemens Logistics, who implemented the Baggage 360 application that they sell into airports, getting IoT data into real-time dashboards that allow airport operators to monitor and respond to baggage being stuck on conveyor belts or somewhere in the airport. So all of these kind of use cases, you can read them on your own, but require really the movement, transportation, transformation of data in near real time. We got a couple of examples that we're going to walk you through where we have some demos. So the first one, John, if you want to introduce it.
Yeah, thanks, Giuseppe. So talking about use cases is definitely interesting, but I think it's even more interesting if you can see it in action. So we have a couple that we're going to show you. The first one is a retail use case. And what you're going to see is how we use real-time data to offer up personalized flash discounts based on buying behavior that we're tracking. In this particular scenario, we're going to be following a fictitious online retailer that's called Congo. If you Google who the second, that's the second largest rainforest. If you Google who the first largest rainforest is, you'll understand the tongue-in-cheek humor. But the basic idea of this is Congo has launched a new line of men's shoes. And the website clicks are fine. Everybody's accessing the website. They're looking at the product and everybody's fairly happy with that. But they have a problem. The clicks are not translating to sales. And in fact, in the monthly or in the daily marketing meeting that happens, they're taking a look at the website traffic compared to the sales. It's not going well. That guy's really upset about it. And what they're struggling with is all of their data is a batch upload of what people are looking at, what sales are happening. They're trying to figure out what's going on in the moment, trying to figure out how to adjust their sales strategy. But the problem is they're always reacting to what happened yesterday instead of what's happening right now, and they can't fix the problem. But luckily, there's some good news. The data engineering team has noticed some patterns that are happening on the website. People are looking at multiple items. They're looking at certain items multiple times. They're going back and reviewing them. And the marketing team thinks this could be a buying signal if people are looking at the same item multiple times. So working with the data engineering team, they figured out that they can pull in data from multiple places to render their website in real time. They're going to pull in pricing, inventory, and user-specific promotions. They can put in one table that lists out the flash discount price for each item, how much they want to discount it based on inventory, what things they're trying to push, and so on. And they can govern that from one table, and then they can render the pricing in real time. So that's the plan to turn around these problems where clicks aren't translating into sales. So to start this, what the data engineering team is going to do is they're going to access the real-time clickstream data, which is in Kafka, add a quick connection and the topic name and the data format of JSON, and then we can preview our data. So when we run the preview and then click on the website, which we'll do right now, you'll see that that record was in fact captured on the index URL, which is the main page, so that we know this pipeline is working. We've got real data coming into the system. So the next thing that we're going to do is put it into our landing place, which is single store. So again, we have a pre-built connection, pretty simple. We can put it in a table of our choosing, and we can run the pipeline. So again, when we click on the website, which we just did, we can query single store. We can see that that record was created. Everything's working as expected with the pipeline. Now, that being said, there's nothing special about what we just did. Almost every data integration tool can do what I just showed you. Nothing special. However, where the StreamSets magic comes into play is what we're going to do next. We're going to build a branch off of this pipeline that's going to perform some real-time lookups. So the first thing we're going to do is add a lookup processor. It's going to go into those tables in single store after we add our connection. And we're going to put in a query to look at all the transactions where people click on something twice within 30 seconds. That's what that query said. I know it was fast. And then we can add additional fields into our stream right on the fly to capture information that we're interested in. So in this particular case, we're going to set up a precondition on the expression evaluator that we only want to pull in data where there's been multiple visits within 30 seconds. So that's kind of the precursor to go into this stage. And then we can build a new field that is program, and we can indicate which discount we are applying to that particular item. And then the second thing we can do is put in an expiration date. Now this one's hard-coded at 30 seconds. We could use a parameter. We could hard-code a different value. It doesn't really matter. And then we can move this modified data stream into single store, put it into a different table name. So that's it. In just a few minutes, we can build this entire process to offer up real-time discounts. And when we run this pipeline, we're going to watch this play out. So you're going to see this go split screen. Now I'm playing the role of a buyer. So I'm interested in the gray sneakers, but at $75, maybe that's a little steep for my pocketbook. So I'll check out the blue sneakers. Well, those are even more, and I don't really like the style. So maybe I'll go back to the gray ones. Those seem like the right ones. And you'll notice it discounted to $69.99. So instantly, it tracked the buying behavior we were interested in, which was 2 visits within 30 seconds, and it offered up this flash discount. Now, you could do other things with banners and alerts and all kinds of things like that, but just to prove out the concept, you can see that very quickly it offered up a personalized suggestion based on the buying behavior that we were tracking. So the next one we're going to cover is financial services, always an important industry for real-time data. This one is about fraud detection. So we're going to show you how real-time fraud detection can help you with proactively identifying anomalies, trigger the necessary alerts and notifications, and minimize loss. As you can imagine, if you catch fraud within 5 seconds, it's a far different impact than 5 days, right? Or 5 months. You have a lot more zeros at the end of that problem if you don't catch it quickly. Okay, so we're going to show you how to build a fraud detection pipeline in about 5 minutes. It'll actually be quicker than that. In this scenario, we're following a Bay Area resident named Raj. He lands at the BART station, buys a coffee. He heads into work a few blocks away, buys a donut, maybe a newspaper. We're tracking all of his transactions, and we're doing geospatial analysis. We can see that it took about 25 minutes to walk a mile. That's 2.5 miles per hour. That's a reasonable distance for Raj to cover in that time frame, so this transaction's okay. But how do we set that up at scale? We do that by building an algorithm. We're going to look at the timestamps of all the transactions that come in real time, and then we're going to calculate the delta between the distance of those transactions and the timing of those transactions. If we divide those two figures and compare it against the airspeed of a commercial jet, we can figure out whether or not this is suspicious, right? Because you can't move faster than an airspeed of a jet and do transactions. This is all going to come in through Kafka in a real-time stream. We're going to do a lookup through a single store table, and then we're going to put the modified data into a single store transaction with additional fields to declare if it's suspicious or not, as well as run a parallel stream into Elasticsearch so that we can do some real-time visualization. So that's the setup. Basically, this is showing you there's nothing built in StreamSets except the pre-existing conditions or connections rather, and we have no pipelines already built. So when we start the process by clicking a new pipeline, we give it a name and we open up in the canvas. Now, one thing about StreamSets is it has 200 plus pre-built stages. So what that means is all of the popular connections you're interested in, like S3 or Elasticsearch or Snowflake or whatever it is you're interested in, those already exist. You just have to drag and drop them to the canvas. In this particular scenario, it's in a Kafka stream. That's where we're looking for that financial data. So we'll do a connection to it, put in the topic that we want to subscribe to, and we'll slow it down a little bit just so you can see it in the demo properly, and choose the data format. So once we've done that, we're going to do the iterative best practice of previewing the data just to make sure that this is working as we expect. So we run the preview, and we can see that, in fact, we do have a record that came through. So far, so good. We've got a good connection to the Kafka stream, and we can continue with our use case. The next thing that we're going to do is a lookup, and we're going to go into that database, and we're going to compare the transactions and then do that calculation that I showed you about the delta. So that's a pretty long query, but that's what that is. And then we can go into the next thing that we require, which is a new field to be created. So in this particular case, we're going to change the output field. I can't even read that. I'm sorry, it's too small, but we're going to add that. And that's calculating the airspeed of 268 meters per second, which is the same as 600 miles per hour, so that we can figure out if this is suspicious or not. And that's actually what that field says. It's a suspicious field that we can flag. And then we land all of this modified data into a transactions table in SingleStore. And then finally, we're going to branch off of this and put it into Elasticsearch so that we have an interesting visual that we can show you. So we set up all the configuration steps within Elasticsearch, and we're ready to go. So just in a matter of minutes, a few clicks, we've built this pipeline. We're going to go ahead and start it. And we're going to load in 5 records initially. So there's 5 that have come in. And you can see that it moves through the pipeline, goes into the Kibana dashboard within Elasticsearch. We can zero in and we can see all 5 of these transactions are happening within San Francisco. Everything looks fine. Nothing's really flagging as a suspicious record. But then we can set up more records in our Kafka stream. We can load in thousands now, which is what we're doing. So you can watch this real-time data pipeline processing it. And you'll notice we have 1 record that's showing up as suspicious. So if we pan out, we can see something's going on in Australia. So we're going to drill down into that record. And what we see here is that 93 seconds occurred between two transactions, but they were 11 million meters apart. There's no way that Raj could have bought something in Australia 93 seconds later than when he was buying his donut in San Francisco. So in a matter of seconds, we can flag that record and people can take action on that in real time. We didn't have to build custom programs. We didn't have to set up, a full application development process. This was done real time within StreamSets and fraud was detected instantly. Thanks, Giuseppe.
Thank you, John. That was really super interesting. And yeah, I've been using the product for what now, 6 years, and what you showed there was really the ease of use of the StreamSets canvas and how easy and quick it is to build pipelines, which is certainly one of the key elements that the population of customers that we have is considering as one of the key features in the product. But I wanted to highlight a few other items that are of relevance, other capabilities that come with the product. So you obviously, John, showed a couple of streaming pipelines. That's the big focus for StreamSets. We'll talk a little bit more about that. There's a couple more things that are really important. A lot of our customers start with, maybe something like what you showed, some Kafka processing or getting data in or out of Kafka. But very quickly, they end up using StreamSets for a whole range of other integration elements. And the nice thing with StreamSets is that you can also create the pipelines programmatically and you can manage them that way. So we look at that for a second. Obviously, flexible deployment. You can run StreamSets wherever your data is and wherever you are as a infrastructure. Probably one of the core elements, foundational elements of StreamSets is this data drift protection. We've been talking about data drift for a long time. It comes from the fact that we started developing StreamSets in the era of big data when not all data is structured. There's a lot of content that is semi-structured or unstructured. It's like JSON document, XML documents, et cetera, et cetera. And the shape and size of those documents keeps changing all the time. So our pipelines are built to deal with that. And I'll talk about that a little bit more. So let's drill into some of these elements a little bit. We talked about streaming. What does that mean? Of course, you need to have a streaming engine. So under the covers, the engine is designed to be a very low latency data processing engine, and it collects data from all sorts of systems. The collection of data can happen in a push or pull through a push or pull mechanism. And as you can imagine, it of course has a native connectivity to a whole different range of standard sort of messaging and event stores. So of course, we support Kafka, Azure IoT event hubs, and things like that. Or maybe if you're in manufacturing or IoT world, things like OPC UA, MQTT, you will be familiar with those. But that's not enough, really. There are a lot of systems that have been designed without streaming in mind, right? You might have databases that they don't really have, an update column that gives you the last update date on a record, and you might be interested in deletes, for example. So CDC techniques to get data from databases are very commonplace, but we plugged in the CDC capability with the streaming capability. So those pipelines that can apply transformations, enrichment, etc., all of a sudden are CDC pipelines that can give you changes from databases. And I would say, super interestingly, is we turn near dumb system like file systems into first-class citizens in an event framework. So we can monitor directories and pick up any new files that are being dropped into a directory or any subdirectory and start processing them as soon as they appear. We can watch for a file tail. So as new records are appended to a file to a file, we can pick them up and process them. And these kind of capabilities are really quite important if you're implementing things like I don't know, log data processing. And it could be logs for cybersecurity, it could be logs for customer interaction, web click analysis, etc. So all sorts of things like that. Of course, connectivity to networks, REST, APIs, endpoints, applications, and so on. All those are built in. So there's quite a wealth for them. Here I'm representing the source systems. Of course, there is a correspondent to this, a whole set of pre-built packaged connectivity to typical destinations and target systems, data warehouses, block storage, databases, etc. So we talked about the streaming engine, and through the demos you've seen that within the pipelines that we build, we don't just move data from A to B. That would be just a simple replication, but we can do more than that. We can apply filtering, we can enrich the record through lookups, we can reshape the record. Very often you will be receiving data from external systems like third-party data, maybe coming in XML or JSON format, and you might want to reshape it, flatten it out, extract bits of those records and send them to your lakehouse or data warehouse or whatever other analytical platform you may want. And those transformations can happen in flight. So it also means that through, for example, enrichment, you can respond to events in real time. That's very important. We're talking about really building these things quickly. So yes, package connectivity, package transformations that are easy to configure. Another aspect that is super important is one of the things I love really most about the product is the interactive preview that allows you to basically check that what you're building matches what you expect to build. So you can plug in transformation objects within the pipeline, just very quickly play it, and you can see what the effect of those transformations is on the data. And that way you can ensure that you've got the right data for your consumers. Now, this is all good. It allows you to build and prototype pipelines very quickly. Typically takes minutes to build pipelines. But what if you have hundreds of systems? And this is clearly the case with a lot of our customers where they are sourcing data from, for example, log files, or it could be databases, and they might have multiple copies of these databases. And, maybe there are templated pipelines that can be built, maybe parameterized, but then need to be executed and run against these potentially tens or hundreds of systems. Well, we allow users to create not only just templated pipelines, but to create them programmatically, to execute them programmatically, to deploy them. And actually, every aspect of the StreamSets platform can be managed through Python-based scripts. This is very important because it basically gives you a higher level of automation and reuse. I think we had some statistics. I can't remember the exact number, but I think it was over 80% of our customers are using the SDK. It really is a massive productivity bonus. Now, next thing is, of course, the platform needs to integrate the systems that you have. And those systems can be on premises in your data center. They could be third-party applications through APIs, REST, or otherwise. It could be in the cloud. So, of course, it needs to have connectivity to all these endpoints. But the platform itself needs to allow deployment of the data collection engine wherever you require. So if you have data on-premise that you want to send to the cloud, it might be of benefit to you to deploy the StreamSets engine on your data in your data center and push the data to the cloud. If you are moving data between clouds, you might decide to put it in AWS versus Azure or Google, however you see fit. The other important aspect, of course, is that this sort of interoperability, interconnectivity is something that we really spend a lot of time and money on, and we keep it up to date. And as new players come to the fore, we integrate with them, and you don't have to. We do the work for you. Last but not least, I wanted to touch on the data drift challenge. So look, this is really quite important. What it enables is two things. One is faster design of pipelines. It's very quick and easy to drop objects on the screen, and as you drop them on the screen, data flows from one to the next. And at runtime, the engine works out what the shape and size of the data is, and the structure is really interpreted at runtime based on a schema on read principle. So all the fields in the record, whatever the shape of that record at that time is, flow through to the target. So you don't have to define individual field mappings. That's a benefit from a design point of view. The other benefit is that, of course, these pipelines are self-adjusting. So if the source system, let's say if a third-party API giving you a JSON payload starts giving you additional fields in the payload, the pipeline will continue running. It will just modify the target system, whether it's if it's just a file like an Avro or JSON, of course, it will just have the additional fields. If it's a table in a database, data warehouse, it will modify the table for you so that the pipeline will keep running. Very importantly, though, you might want to be made aware of the fact that changes happen. So we can create alerts and notify you of the fact that changes occurred. So you have both the flexibility of having the pipeline continuously running, as well as the alerting and control that you can have around it. So with that, I think that was an overview of StreamSets. I'll hand over to Jordyn to talk a little bit about where we're going next.
Thank you, Giuseppe. So good morning, good evening, good afternoon, everyone. My name is Jordyn Jaffe, and I'm a product manager for watsonx.data integration. And so today we've heard a lot about streaming data. However, did you know that 87% of organizations use actually 3 or more data integration tools? And I'm seeing actually in the chat that this holds true with the need for replication and ETL and ELT tools. So why is this the case? Well, first, different use cases, you need different tools. And then second is every time there is a new shift in technology, you need new tools and ways to store data come along and disrupt how data engineering works. Data engineering teams often feel very overwhelmed. And because each change, organizations must rethink their data strategy from scratch. This constant evolution isn't just about new technology, it's really about changing where and how clients store their data. And from data engineering perspective, this really means having to rewrite pipelines and redo those pipelines from the previous work as they move from different architectures. And Giuseppe touched on this at the very beginning, that 50% of data engineering's time is actually spent rewriting those pipelines. So if we go to the next slide, to address these challenges, IBM recently announced watsonx.data integration. And watsonx.data integration acts as a single control plane for data teams. It really brings together the powerful capabilities of ETL, ELT, real-time streaming with StreamSets, replication and data observability, as well as unstructured data, all in one place. So this really means that teams can manage complex integrations more easily through a single pane of glass, simplifying their workflows and reducing the need to juggle multiple tools. So going to the next slide, with watsonx.data integration, IBM provides a unified control plane to build data pipelines that aren't tied to a single integration style or storage system. So this really means that there's no more dependencies on one tool for one use case, and it really gives teams the flexibility and freedom for one tool for many use cases. So what I'm going to do on the next 3 slides here is talk through the 3 key pillars of our strategy that will transform data integration. So the first pillar here is the comprehensive data integration capabilities. watsonx.data integration covers the full spectrum. As I have mentioned, it blends multiple integration styles like batch processing, replication, real-time streaming, structured and unstructured data, and it's all backed by our strong data observability tool to keep everything running smoothly. Our second pillar on the next slide is pipeline authoring experience. watsonx.data integration makes it easy for anyone to build and work with data pipelines, no matter your skill level. So whether you're, a business analyst or a data engineer, you can use this tool to get the most out of your data and help bridge that skill gap that's holding a lot of organizations back. So essentially, if you want, that low code, no code, you can simply just drag and drop components to design a pipeline. We're also making it easier to create pipelines with a new natural language powered assistant through an interactive chatbot built on watsonx Assistant. So you basically just tell the assistant what you want your pipeline to do, and it'll build it for you. It's basically like having a personal pipeline builder at your fingertips. And then for our more technical users, you can build, customize, and manage pipelines programmatically with SDK for Python. And then on the next slide, our last and third pillar is workload adaptability. This architecture separates pipeline design from storage systems and executes and execution of engines. This lets you reuse pipelines without rewriting them every time your storage technology changes. And you can also dynamically optimize pipelines based on workload needs. So to help you, balance cost, performance, and other factors as well. So as you can see, you're able to gain access to StreamSets and its capabilities in watsonx.data integration, along with gaining access to other data integration styles and tools to adapt as your organization grows, as well as your needs change. So we'll also have a more in-depth webinar on watsonx.data integration on July 2nd to go more in detail on the features and benefits of watsonx.data integration. So please stay tuned on how to register for that as well. So now I'm going to pass it back to Simon to close us out here.
Thanks, guys. We're keeping to time really nicely. But just to finish off the webinar, what we're offering all customers, and if I end up with too many customers that I can cope with, that'd be a nice problem to have, because we've got the extension of IBM to give us the capacity to help any customer that comes to us with any of these use cases. But clearly, we're in a position to do demos, live demos. We can do them in person at your offices, or we can do them very, very quickly. As you've just seen with Giuseppe, he's shown you how simple the product is to actually get cracking. So it only takes half an hour for you to kind of show you the palette and how to use it and how simple it is, or we can go into a deep dive. But the real one that I wanted to kind of draw your attention to is it's because it's so simple to use and stand up and actually put your data into it. We're willing to offer any customer what we're calling a builder use case. So if you come to us with a particular use case in a pre-sale, non-production state, we'll build it with you and demonstrate the value in real time, so you can actually see the product at work with your data and get the outcomes, and hopefully that will help you accelerate the adoption. But clearly, you're also welcome to attend any future sessions and look on ibm.com for further information. But that's kind of where we got to for the webinar content. We've had a handful of questions and answers come through on the Q&A. So my understanding of the Zoom webinar features and functions is that you should all be able to see the answers now, and indeed the questions that were put to us.
Okay, so I've got a couple of questions that have been asked, sort of technical questions around, what is the engine based on? It's a Java-based low latency processing engine, so based on sort of micro batching technology. So of course, like all data integration technologies, you need to balance latency for throughput. We give lots of options for really optimizing for the specific workload that you have. We run, as I said, it's a Java based. It runs in a JVM. It can run on containers. So if you're on Docker or something like that, that's great. If you're on Kubernetes, that's great too. By the way, you can deploy to whatever Kubernetes infrastructure you may need or want. Could be AKS, EKS, GKS, could be, of course, OpenShift or anything else. Yeah, so low latency, but also high performance through both scale up and scale out kind of approaches. So that's probably answer to that. I see there was another question about NiFi. Quite different, really, in a way. So in principle, it's similar. Look, lots of, all data integration technologies ultimately have package connectivity, get data from A to B to some extent. But our focus is very much around record level processing and in-stream, in-flight, low latency manipulation of records rather than movement of files from one place to another. Also, we have a very strong separation of concerns between the control plane and the data plane. We have a very sophisticated control plane where the pipelines are authored and providing a multi-user, multi-environment, maybe multi-project actually environment for managing large number of pipelines across a number of projects, sharing assets between them. So very rich and also very very governed in a way. So we produce a lot of operational statistics, which we surface up in the product, but also in the broader IBM observability components to offer visibility of end-to-end pipelines, which may not just be streaming pipelines. It could also be ETL, ELT pipelines, etc. And potentially you have many of these stitched together to deliver data from source to consumer, and we can provide end-to-end management of those pipelines.
I think again, I'll just conclude by thanking you guys enormously. It's as I said at the beginning, it's a very exciting prospect to actually bring StreamSets to our customer base. But just in closing, as I also mentioned at the beginning, we're hosting a specific session on watsonx.data integration that Jordyn will be taking you through a much deeper dive on the complete control plane on all of those different products and tool sets on the 2nd of July at 3 p.m. as well. So if you found this one interesting, and I hope you have, if you haven't, ping me a notice afterwards about what we could do to improve the user experience of this webinar. But we'll be broadcasting that invitation over the next few days for the 2nd of July. So we look forward to hopefully giving you some more content in 4 weeks' time. But thanks again to the IBMers.
Thank you, Simon.
Speak to you all soon.
Bye.